I'm John Goglia.
And I'm Greg Feith. And we are the Flight Safety Detectives. We're just two guys who have spent most of their career with the National Transportation Safety Board investigating aircraft disasters and aviation safety issues all over the world.
Yep, and this podcast is where we talk about everything from accidents, airplane technology, to the big business of aviation.
We live and breathe aviation. My co-host John has been in the aviation business for more than 60 years. He was the first and only airframe and power plant mechanic to get a presidential appointment to the National Transportation Safety Board.
And Greg is a former air safety investigator and GO team captain for the NTSB. He's investigated everything that flies worldwide since he started his career 40 years ago. And on top of that, he is a Living Legends of Aviation inductee.
So between John and myself, we have over 100 years of aviation safety experience. It's time to buckle up, because it's going to be wheels up. Let's get this show in the air. Boy, we have a lot to talk about today. John and myself, we've read the recently released safety recommendations by the National Transportation Safety Board pertaining to the 737 MAX. And given the fact that these recommendations are coming out in advance of any official report, including the report that we're all waiting for from the Joint Technical Review Team. There's a lot of stuff to talk about, especially with these recommendations and how they pertain to the industry and some of the things that the NTSB is recommending to the FAA and Boeing and other manufacturers with regard to aircraft certification and pilot interface with the aircraft. So with that, I'm going to bring on John and say hello, and let's get going.
We're anxious to get started on this because of the sheer volume of press reporting, 90% of which is inaccurate. And we hope to set the record straight for all of us in aviation that depend on accurate information to make good decisions. So with that, Greg, you can have the first go at it.
Yeah, well, the first go. I just want to let folks know that this is going to be a multiple episode discussion. We're not going to try and catch it all in this particular episode. This is going to be an ongoing thing. There is still so much information, not only in the recommendations, but of course, we're waiting for the official report out of Indonesia. We're waiting for the official report out of Ethiopia. And of course, as I said before, we're waiting for that Joint Technical Review Team and their report to see how all of this information interfaces with each other. The NTSB has taken the stride to put out some recommendations to the FAA in advance of this. I've read through it, John's read through it, and I've contacted a number of folks, as John has, in the industry, getting their perspectives as well. I read it and started shaking my head because I don't think that this hits the mark. It goes a little too far, and the requirements that the NTSB wants of the FAA and manufacturers, I don't think is possible. And I know that one of the things that when I was with the NTSB, and I know that with John, when we were there together, when we talked about recommendations, especially those going to the FAA and to the industry, but primarily to the FAA, we wanted to get information from the FAA with regard to the recommendations so that we knew that when we wrote them, they were going to be something that the FAA could actually do. And I'm not sure what kind of interaction the FAA and the NTSB had prior to the release of these recommendations. But just first blush, looking at it, I don't see how, one, they're viable, and two, they're possible to even obtain. John and I are going to give you our opinions. I've got some very strong opinions, as I know John does, and I think the industry does. And so in looking at the recommendations, we're going to start with dissecting a little bit of Lion Air. We're going to talk about Ethiopia and then talk about, in a global sense, the recommendations that the board wants of the FAA and Boeing based on these two particular accidents. So starting with Lion Air, we have to, as we've talked about in previous episodes and of course in the news media that John and I have done, we have talked about the fact that this accident didn't start on the day of the accident, but in fact started as a sequence of events well in advance with maintenance actions that the Lion Air folks had taken. So, John, in your dissection of some of the things that we know about Lion Air and the maintenance actions, what do you think starts this whole ball rolling with regard to the failures of a system or systems and the interaction between the pilots and the aircraft?
When the airplane came into maintenance 2 nights before the accident, maintenance had write-ups with airspeed and the angle of attack indicator was replaced. And it was replaced with a unit that was sourced from a facility in Miami. It's not clear, and we're not throwing stones at the facility in Miami. It's not clear if it was new or used. It appears to be used, time continued, which most of the time means it came off another airplane. And it may or may not have been overhauled. It may have been bench checked. We don't know based upon the information that's came out so far. However, what is clear is they didn't do a very adequate job of checking the airplane. Now, I understand from people in the industry that they were on the phone with Boeing trying to get help. And I don't know that to be accurate, but that's what's being talked about. So they were on the phone with Boeing. Boeing will give them all the technical help in the world, but they're not going to fix the airplane for them. They're not going to sign the airplane off. And when I saw some of the write-ups and the sign-offs that occurred in that first place, and I've been in print in the New York Times being very colorful about the remarks that I said about it, and I stand by those remarks, that I don't know of anybody here in the U.S. that if that airplane came in with those kinds of write-ups, that airplane would have left.
When you talk about the fact that the AOA vane that the maintenance folks at Lion Air did receive, this was a brand new airplane. Why didn't they just go to the Boeing field service reps, who that's their job, as I understand it, is to interface with the airlines? Why didn't they just go and say, hey, this is a brand new airplane. We need a replacement part. Isn't this airplane under warranty? Don't we have a bumper-to-bumper warranty? Give us a brand new AOA vane. Why would they have to go to a third-party parts facility to get this AOA vane?
Yeah, an unanswered question. I hope that the investigation board asked that question. Why did they source this part from where they did? And also, there's another question in here. There's a tool that you have to use after you change just to verify the position. And that tool's not located at every station. So did they have one? Could they have gotten it sent in on the overnight? That's one of the questions I hope the investigators have asked already and got answered. And there's another problem in here that we just brushed over. And that is, as I understand it, this facility is not part of Lion Air. It's a third-party provider that's owned by the same umbrella company, but they are a third-party provider. What's the level of training of people they have? We had in a previous podcast somebody on that told us that they do 5 or 6 untrained people for every trained person. Who worked on this airplane? Were they the trained persons? And can we be assured that the person's name that appears on the paperwork was in fact the person who did the work?
And the NTSB in the preamble, if you will, to the recommendations, they have a factual information section, and they do a synopsis of both accidents. The first one, of course, being Lion Air. They do talk about a bit of the history, and again, it's taken from the reports that have been issued by the Indonesians thus far, which is their preliminary report. They talk about the fact, and here's another issue. There's a lot of press out there, and a lot of press was made about the fact that this airplane may not have had 2 angle of attack vanes on the aircraft. That's a misnomer. The fact is that both Lion Air and Ethiopia did have 2 angle of attack vanes on each airplane. The question was whether or not they actually spoke to each other. That is, did the left side compare to the right side, and then was the pilot or the instrument then provided sufficient information if you had a disparity. We know for a fact that both airplanes did have the AOA vanes. There was a disparity, and the disparity that happened on the Lion Air airplane was about a 20-degree difference between what the left AOA vane was indicating versus the right AOA vane. And you and I had this conversation, John, about, when you put the AOA vane on, it's not like just bolting it on and, sending the airplane out. Don't you have to calibrate it and do all those things?
Of course you have to. You have to make sure that it's working. You have to make sure that it wasn't damaged. There's a receiving inspection required for damage. And also the mechanic maintainer who puts it on the airplane has to also do an inspection before he installs it on the airplane. And I've seen many people in these repair stations that don't understand their responsibility in that area.
So now the question is, I hope that the investigators will be really pursuing, and that is, did these folks follow the GMM or the maintenance manual and the maintenance procedures to the letter when they installed this? It's obvious that there was a disparity of 20 degrees between the left and right sensor, which would indicate that there's a high probability that they failed to follow parts or all of, the particular procedures.
Greg, you just touched on something a few minutes ago about the identifying the differences between the left and right AOA indicators. The job of the pilot not flying, if he sees something irregular on his side, is to compare it with the one on the other side, which would have given him an immediate cue that he had one side was not operating the way it should be operating. So a miscue in the very beginning. And as we go through this report, there's a number of places where pilots in one airplane or the other missed the cue.
And when we look at those cues, again, even though we have two airspeed indicators on the panel, the left side for the captain, of course, the one on the right side for the first officer, there is also a tiebreaker, if you will. There is a standby airspeed indicator. There's no information, and again, and I will qualify this a little bit, that the NTSB, they put a synoptic together based on preliminary information from both Indonesia and Ethiopia. There's a lot of detail they have left out in their introduction of these accidents that I know about, that I know you know about, John. And so it doesn't necessarily put each of these accidents in context as far as all of the things that the crew may or may not have been doing, seeing, or the instrumentation that was available to these pilots, such as the standby airspeed indicator. If you have unreliable airspeed because you have a bad angle of attack vane, and it's giving erroneous information with regard to the angle of attack, which has an adverse effect on, quote, the airspeed, you got to look for other elements or other tools to use to determine what's right and what's wrong. But the board did talk about the fact that there was this disparity of about 20 degrees, that the angle of attack sensor or vane on the left side was reading 20 degrees higher than the right AOA vane, and that during rotation, that is, as the airplane was taking off, it was configured for takeoff with flaps down at a particular takeoff setting. As the airplane rotated and broke ground, the captain got the stick shaker, which on large transport category airplanes like this, it vibrates the control yoke to tell the pilot that he's in a potential stall condition. That is an aerodynamic stall. And it was because of the miscalibrated AOA vane that inadvertently triggered that stall warning. Now, of course, that'll get the pilot's attention because the control yoke is shaking. But that's the point in time where the pilots need to be working together as a crew to determine, is this actually happening? Are we in a stall condition? I had a similar event that I investigated back in the late 80s with TWA and an L1011 where they too had an angle of attack vane problem. They did get stick shaker right at rotation. And of course, the pilots start going through, well, you got good airspeed, and the flight engineer was telling you got 3 good engines, keep going. And then unfortunately, because the pilot who was flying was the first officer, he decided he didn't want to fly the airplane anymore, tried to transfer command of the airplane over to the captain at a very untimely point, and the accident sequence started. But in this case, you're looking to fly the airplane. That is your primary job as a pilot, is to fly the airplane and use the tools available. So they got stick shaker. Again, not knowing whether, MCAS and having any information about MCAS to these pilots, that didn't matter at that time because, one, MCAS didn't trigger with the airplane configured with flaps down. But the fact that they had to deal with whether or not this unreliable airspeed issue, which is a trained event, was handled properly. And it'll be interesting to see how, of course, the Indonesians dissect all of these, sequential elements that eventually led to the loss of the airplane. But again, as we just talked, it starts with the maintenance issues, because as you described, John, if they put this bad AOA vane on, now the crew that flew it right after the initial installation, they got the erroneous indication of a stall warning with the stick shaker occurring the day before in this accident airplane. But as the NTSB describes through information from the Indonesians, that crew was able to identify that, in fact, they had a unreliable airspeed, and they performed the procedures that were necessary to handle that unreliable airspeed. And then when they reconfigured the airplane with the flaps up, that's what triggered MCAS at the time, and they got this uncommanded trim roll. That is, the system was trying to trim the nose down because of the erroneous indication from the AOA vane saying the airplane's in a stall when it actually wasn't. The crew, through the use of not only their own resources, but they fortunately had a jump seat rider on the airplane who was there to assist as well. They were able to perform the appropriate procedures, the stab trim cutout, and actually fly that airplane successfully, even with the MCAS being triggered because of the erroneous information, and were successful in getting the airplane back down on the ground. It didn't take any extraordinary skills. They flew the airplane, they got it down in one piece. And so the question is, did they report after that event adequately to the engineering group what had happened, and did the engineering group go back and do the proper procedures to remedy that situation? I would have to question it, John. I don't know about you, but I sure would have to question it if a crew came in and said, hey, this is what happened. And, they look at the airplane and they return the airplane to service on the accident flight. I've got real issues with that.
I was told that there was no write-up on the inbound flight. They may have given a verbal to maintenance, which is not what you're supposed to do, but they may have done that, but there's no record of them letting maintenance know on that second day that they had problems. And I wanted to clear up one point that you said, Greg. When Greg talked about when they raised the flaps up, that it triggered a MCAS event. MCAS is biased out or blocked out while the flaps are anywhere but full up. So another clue was missed by the pilots when they put the flaps up and they immediately have a problem. I was taught when I flew years ago that if you do something and you get a problem, to undo what you just did.
Yep.
And it was immediate when the flaps hit all full up. It was immediate. The trim started to move.
Yeah.
So they missed that cue as well. And never mind looking out the window to see that the horizon is where it should be, not under the airplane.
And of course, the pundits out there are going to go, well, they didn't know about MCAS. It did not matter whether it was MCAS or just a true runaway trim situation. Pilots are not going to analyze, wonder if that's MCAS that triggered that, or it's a motor problem and it's just a runaway trim or a circuitry. You're going to react to the fact that trim is moving uncommanded. You do the things necessary that you've already been trained to do and are familiar with a runaway trim, because MCAS mirrors a runaway trim. It moves the trim. And so the MCAS, while it is a command to the system to move the trim to an airplane nose down attitude, whereas uncommanded trim can go either nose up or nose down, the fact is that pilots are reacting to the fact that the trim is moving without command. And they need to react to what does it take to stop that movement and maintain control of the airplane. We'll figure out what the origin was later on. And that's what the crew did the day before. They were able to identify that they had an uncommanded trim stabilizer runaway, basically. That was the procedure. They went through the procedures. They manually trimmed the airplane and came back around. And so, the question is, why didn't the next crew, which was the accident crew, identify the same thing? And we'll get into training and a bunch of other things with regard to that, because pilots are not cut out of the standard cookie cutter, if you will. And so when you look at it, if the accident crew had done the procedures of runaway trim and they had turned the auto throttles off, which they did not do, that's why they were at such a high speed. Now the question is whether or not we'd be talking about that as an accident. It's obvious that we are, because they failed to follow appropriate procedures. From a maintenance standpoint, we're going to find out more information. But from this point forward now, it's that interface between a broken airplane, if you will, and the flight crew.
It's not just broken. It's an unairworthy airplane. The crews on the day before the accident were handed an airplane that was not airworthy, and the crew on the accident crew was handed an airplane that was not airworthy. So maintenance has their hands into this way too much. And I've been preaching for a while that maintenance involvement in accidents is on the way up for a number of reasons. But it's evident when you look at what's going on that we're getting more and more maintenance involvement in the chain of events that lead up to an accident. And in this particular case in Indonesia, the link is big in maintenance. It's not a little link. It's a big link, big involvement. So we got an airplane it's unairworthy. We've turned it over to a crew that has missed at least 3 cues in the system to help them identify the problem, and they keep on trucking.
Yeah, exactly. And so then the safety board in the recommendation preamble talks about Ethiopia. Now, given the fact that we have very similar circumstances, right at rotation, the crew, the captain was the flying pilot apparently, based on this information, and they had a problem, again, with the AOA vane. Now, what they were able to determine, which distinguishes it a little bit from the Lion Air accident, is that in Lion Air, there was only a 20-degree difference between the left and right AOA vanes or sensors. In the Ethiopian accident, the sensor, the left side sensor, the captain's side, increased rapidly, as according to the words they use, to 74.5 degrees, which was almost 60-degree difference between the first officer of the right side probe and the left side. So now you have this big disparity, you have this erroneous information, and of course, because the captain's flying, it's on his side, and the captain's AOA vane is indicating this extreme angle of attack indication, even though it's erroneous, it too triggered the stick shaker. And again, now the pilot and this particular crew, the Ethiopian crew, had been trained supposedly, according to all the media reports, all the interviews with the CEO of Ethiopian Airlines about how well trained his crew was, that they were trained to the new procedures that came out from Boeing through an airworthiness directive that reiterated that they used the runaway trim procedures. Supposedly, this crew was well trained for that. And so when this airplane took off, they got stick shaker, which is an indication of a stall. They were supposed to handle that particular instance because it's unreliable airspeed. It had nothing to do with MCAS because the airplane was still configured with the flaps down for takeoff, which would have inhibited MCAS, as you talked about, John. The autopilot has to be off as well. That's the other parameter. The autopilot in this case was off, but the auto throttles were still engaged. So the pilots take off, they get stick shaker, and everything was copacetic with dealing with just the stick shaker event. They did get a master caution alert on the Ethiopian flight. And then, soon as they pulled those flaps up, soon as they retracted the flaps, that's what is the arming of the MCAS system. Soon as those flaps came up, all of a sudden the trim started moving nose down because MCAS is saying you got too high an angle of attack, even though the information was erroneous. The crew knows that the airplane isn't standing on its tail. It's 75 degrees nose up. They can look out the window. They got an artificial horizon. You got to get back to raw data. You got to get back to airmanship, and you got to use the tools that are available. And the NTSB in these recommendations are talking about all of the alerts and warning overload, and we'll talk about that as well. But the fact is that the crew was dealing with one issue, and that was unreliable airspeed. They got the stick shaker. They have to deal with that. That's very easy to deal with because the pilots have been trained to this, and that is pitch and power. Find a pitch, find a power setting, which there's pitch power information in the flight manuals, and you deal with that. You fly the airplane. They got another warning, which was likely the overspeed warning because they were overspeeding the flaps for the configuration because, again, they had the auto throttles engaged. And at takeoff power, they're going to zoom through any kind of, speed with the flaps down that have all the flaps have the speed limitation. They zoom through that, and of course they're going to get an overspeed warning now. So now they've compounded the initial warning, which is the stick shaker, and next thing you know, they are dealing now with these multiple alerts and warnings, some of which were induced because they were not really plugged in to fly the airplane as it should have been flown. All they do is turn the auto throttles off and slow the airplane down, pull the power back. But instead, they reconfigured the airplane, they pulled the flaps up. As soon as they pulled the flaps up, that's what armed and then activated the MCAS system, because it starts running the trim nose down. So now they have an uncommanded trim to deal with, as well as this inadvertent stick shaker because of the bad information. And so now all of a sudden they're running the trim, or the trim is running. They did do part of the procedure, and that was they did go to the stab trim cutout, which turned off the electronics or the electrical current to the system. They did turn that off, but because the airplane was accelerating so much, all of a sudden now physics takes over. The higher the speed, the higher the aerodynamic loads. And trying to turn a trim wheel that's sitting right next to the pilot's knee, that's the size of a pie plate, as the airspeed increases and the aerodynamic loads increase, there's a point where you're not going to be able to retrim the airplane manually turning that wheel, because the aerodynamic loads on the stabilizer are so high. All they had to do was pull the power back and slow the airplane down.
Wouldn't you think they would have got the clue when they tried to move the trim manually and they couldn't do it, that there was something else going on, like maybe going too fast?
Well, in fact, John, they did try to do that, but they didn't analyze it as going too fast. They thought that there was some sort of trim issue, so they re-engaged the cutouts, so that now they put positive energy back into the stab trim, thinking that they're going to use the trim button on the control yokes to move the stab trim, when in fact that just re-energized or re-engaged the MCAS to drive the trim further down. And again, they had the auto throttles on. That's why these airplanes, both of them, hit at excessively high speeds, over 400 knots. And that's because the auto throttles drove the airplane into the ground at a high rate of speed. All they do is pull the power back. That's called airmanship. That's called being a pilot. And these pilots have been trained for runaway trim events, well, at least we hope these pilots have been trimmed. We don't know their training program, and I sure hope that both investigative authorities have dissected the training thoroughly, because it's one thing to say, yes, these pilots completed training, but what was the level of training? What were the elements of training? And what was the accomplishment of all of these elements by the respective pilots? Were they exposed to it, or was it just demonstrated? Or here in the United States, pilots are required by the FAA to demonstrate to an examiner the mastery of certain procedures and that kind of stuff. You know, what was the element of training with these folks?
You know, all the pilots that I talked to after the first accident, I flew a MAX the night before they grounded it. Every one of the pilots, U.S. pilots, love the airplane. They all love it. So there's got to be a very large element of training in this issue. I mean, ICAO specifies a minimum training for pilots, and also a minimum training for some mechanics. We don't train all our mechanics outside of the U.S. We don't even train them all here in the U.S. So, but there is an element of training required on every type airplane you work on, and obviously the ICAO standard should be looked at. And then one of the things that frustrates me when I look at the document that the NTSB put out is it's not one word referencing that, but we'll get into that in a little while.
Absolutely. And you did bring up another point, and that is, you know, in all of our pilot training, if you have done something in the airplane, you moved the flaps or you did something else, you put the landing gear down and something bad happens, we've always been taught, undo what you just did. That principle applies in the fact with Ethiopia, the pilots did go to the stab trim cutouts, but then they re-engaged the system rather than just going raw data and flying the airplane with airmanship. And that's what really put them in a position of jeopardy, because as soon as they re-engaged the stab trims, that re-engaged the MCAS to do what it was designed to do. It didn't know that 74.5 degrees was erroneous. It just got the input. And so, the pilots, unfortunately, again, put themselves in a very bad position. Now, everybody out there is going to go, oh, you're covering up for Boeing. It was a bad airplane. Trust me, it is not a bad airplane. And when you start to dissect, and we've talked about this, and we're going to continue to talk about this, you have to take all of the aircraft certification out of the loop. You have to look at the facts, conditions, and circumstances of each of these respective accidents. You have to dissect them for what they are as far as the elements, whether it's maintenance, whether it's crew operation in the airplane, training, it does not matter. You have to look at those in isolation. You then have to look at the common denominators between the two accidents and the event that took place the day before. And then you start to look at, okay, what were the elements of each of these accidents? Could they have been prevented? Well, it's obvious that the day before, the crew was able to prevent any kind of adverse situation with the airplane by following procedures. But now everybody wants to hang this, especially these recommendations put out by the NTSB. They want the manufacturers now to make up for the shortcomings, the incompetency, the lack of skills, abilities, knowledge, and experience, whatever you want to call it. They want the manufacturers to put enough protections in those cockpits to provide the pilots with guidance on how to fly the airplane. The whole reason you're in that level of flying and in that level of aircraft, a transport category aircraft, is because you have the requisite skills, abilities, and knowledge to understand and be able to handle situations, abnormal situations. That's why we have an abnormal checklist. That's why pilots are trained for runaway trim and other circumstances. And to get into alert overload, that's obvious, and that is something that has happened in the industry, especially with these automated airplanes. But that shouldn't be the basis to put the onus back on a manufacturer to try and keep a pilot out of trouble because they don't have the requisite skills, abilities, and knowledge to be able to do what is required and prioritize whatever actions are necessary for them to take to correct or maintain control of the airplane. And I mean, this information that's put out by the NTSB, it goes into a lot of that, John.
When I read this report that they put out, I was on my phone. I was beside myself. And after I calmed down, I started to think about it, and I looked at it again, and I can tell you that if I was still on the board, this report would have went out with my dissenting opinion on it. I would not have agreed to this. This reverses 30, 40 years of precedent that the NTSB has had to build the qualifications in the cockpit, not to dumb them down, my words, not to take the qualifications away. If I get on an airplane, I expect to have a pilot that knows what he's doing. And what this document's saying here is that we can lower that a little bit. We can make up for some of the deficiencies. Well, the washout rate for pilots sometimes can be 30% of a class. That means we're going to build our cockpit so that those 30% people wash out. That means that a D was going to be a good enough pilot. I don't know. I want an A, B, or at least a C. All right. We need to make sure that we maintain our pilots and their skill levels so that they can fly without automation. I mean, we've had a number of cases come up where we've had pilots make mistakes in airplanes, and we went back and interviewed it. It wasn't a crash. It was an incident reported usually by air traffic control. And I'm thinking about one we had in the West Coast where that pilot was an international pilot, and he hadn't flown the airplane in more than 90 days. Every time he got on the airplane, the captain said, I got it. They mixed crews in this particular company, so his return leg was with a different captain. So he hadn't been flying the airplane in 90 days, and he almost had an impact with a mountain. So, I mean, I want pilots that know how to fly and fly often enough that they're familiar with it in the airplane. And then I want a maintenance organization that cares about their pilots and not the schedule.
John, as we've been talking, there again, the recommendations that have recently come out are just voluminous as far as the information that leads up to what the board is recommending to FAA and of course, Boeing and other manufacturers. And so trying to hit it today in this particular podcast will be impossible. So I just want folks to know we're going to dissect each of these elements as we continue on. And of course, as we get more information through the official reports from Indonesia and Ethiopia. But when we get down to the bottom line and at least the logic that the NTSB is trying to use in supporting these recommendations, I know that I've talked to a lot of people who have read it, and you have talked to a lot of people, and they just shake their head because everything that we're talking about is in fact contrary to what we've been preaching, at least here in the United States and actually, parts of the world. And that is, you cannot build an airplane, even if it is as complex as the current airplanes that we use today in commercial airline service. You can't build an airplane so that it makes up for the shortcomings of the pilot. Sullenberger has even said that, you can't make up for experience. And that is, you got to have the pilots that have experience. And when you have a 200-hour first officer who just transitioned out of a Cessna 172, and now they're into a jet aircraft, and now you have a situation like this, what help is that pilot going to be in accomplishing the requisite procedures to the captain who's trying to do everything in this particular instance? And again, we saw this in a number of accidents, and the NTSB put out a lot of recommendations in the Colgan accident with regard to experience and training. That's how we got to the 1,500-hour rule.
Yes, no question about it. It goes back that the accidents with first officers with low time, it wasn't just one accident, Colgan, that led to that rule. There was a number of them. The first officer on ValueJet had a lot of time, but he could never transition because he wasn't a very good pilot. Right? So how we can say that we want to dumb down the cockpits through automation and not reinforce the training is beyond me. I mean, we talked about it over and over when I was on the board about having a qualified crew members, both of them qualified. Remember, there used to be 3 up front.
Yep.
A lot of those bells and whistles that the crew was getting would be handled by the flight engineer.
Exactly.
But now the automation just rings the bell, and the captain and the first officer got to figure out what it means.
And when you look at what the board wants, where now they want the manufacturer to determine the hierarchy and the priority of what these alerts mean. First off, there is no way. One of the things that the board has put out, again, they are critical of the certification criteria that has existed for a very long time, that has formed the basis for the certification basis of a lot of different aircraft, both built here in the United States and elsewhere. Through EASA and other regulatory organizations, they have the same philosophy. There are assumptions that have to be built in. And to say that, well, now we got to take this airplane down to the lowest common denominator, the average pilot. Well, first off, who's going to determine what the average pilot is, or who that average pilot is? Because I guarantee that the lowest common denominator, the pilot in Indonesia, Ethiopia, or elsewhere, is that pilot the average pilot? Is the pilot here in the United States the average pilot? Where is that in between?
When we did Accident 427 in Pittsburgh, I worked for the company involved, so I was sort of in the background. I didn't vote on the final product, but we did have what we determined to be an average pilot that came off the airline's property and flew the airplane when we did testing, right? And he was deemed to be an expert average pilot. All right. And I would tell you that if he was flying this 737, these accidents would not have happened.
And the fact that in the criteria, the certification criteria that has been missed and not really talked about in the media, because these, again, are very complex issues, very voluminous type issues to try and, get across in a 10-second soundbite. The regulatory requirements say basically that the airplane has to be designed and has to be operational to the point where a pilot doesn't need to use extraordinary skills, or, as I always call it, Chuck Yeager type skills and knowledge to identify and remedy a situation and maintain control of the airplane. That's in the certification criteria. And so, it has to be obvious. If there's a failure or some sort of system anomaly, it has to be obvious to the pilot, which when you got this big trim wheel moving in a 737 that's painted black and white and it's moving right next to your leg and you see it moving and you're not pickling the switch and your co-pilot's not pickling the switch, but it's moving uncommanded, that's pretty obvious that something's going on that you need to take some corrective action to. The other thing is that with all of these bells and whistles, the board wants the manufacturer through the FAA to determine a hierarchy of priority. Well, first off, there are so many different combinations, thousands of different combinations of alerts, because you don't know in any particular situation what in fact is going to trigger one or multiple alerts. So using their philosophy and their basis, in this particular instance, if there was some sort of hierarchy, who's going to be responsible? The machine to determine what the hierarchy is to fulfill the pilot's need to take control or maintain control? Or is it the pilot that we require to understand what the hierarchy is? It's very simple in my book. The fact is that in these particular instances, your two first priorities are airspeed and altitude and maintaining control of the airplane. And to
fly
do
the
that,
airplane.
Fly the airplane. That's called airmanship. We preach it all the time here in the United States and around the rest of the world. But is this really being taught? It's evident. We've seen in past accidents where there have been some shortcomings with pilot training. I would be very interested to see what type of and depth and breadth of training these folks are getting, because it's obvious we're not having problems here in the United States. We're not having problems in places elsewhere. So I think training is going to be a big issue. But for the board to say that you have, and they use the word, their wording says that, and I'll find it here in a second, but when it talks about the fact that they want the manufacturer to come up with all possible scenarios that would trigger alerts and warnings, that's just virtually impossible. There's not a manufacturer, whether it's Boeing, Airbus, or anything, you cannot come up with all the possibility. And as we get more automated and you have the electrons flowing back and forth for all this electronic equipment, there is a multitude of possible triggers for multiple alerts and warnings. The second part of that is, what are you going to do? Write a procedure for 10,000 different possible scenarios? And then, that's going to make flight manuals, inches. We're talking feet thick now. And then how do you train the pilot to it?
Airline pilots go through at least a month of training, learning the systems on their airplane so they can identify when these problems come up. They can identify what's a normal system operating, and they can identify some of the problems with the system when it's abnormal. You can't script all that.
No, you can't. You're absolutely right.
Could a computer that was flying Sully's airplane do what he did? Guaranteed not.
Absolutely, because it's not that intuitive. I always preach that the most flexible and adaptable machine today is the human. We can adapt and make decisions on the fly based on new pieces of information. A computer can't necessarily do that, especially in a very dynamic situation. And, as a good friend of mine, and he's a good friend of yours as well, we've talked about this situation. He goes, you can't come up with an engineering solution for an operational problem. There are some operational problems out there that just don't have an engineering solution. And the board is looking to the manufacturer to provide that. The guidance on how to fly this airplane. That's what being a pilot's all about. That's what training is all about.
Yeah, so the NTSB wants identify non-normal operation of an airplane system and determine the appropriate actions, if any.
We train to that now.
That's exactly what I was going to say. That's normally what we do. And it takes about a month of classroom training, 8 hours a day, plus a ton of homework for most pilots, right, to be able to demonstrate that they know how to do that at the end of the day.
And, the fact that, you and I have gotten on our high horse over the past several months, the fact is that, okay, if you look at Lion Air, everybody is bound and determined to say that Boeing didn't have the discussion about MCAS in the flight manual. Well, first off, it's a transparent system. The fact is that it was originally in the flight manual. Boeing and the FAA, particularly the FAA, because they are the certifying authority, allowed that information to be removed from the flight manual because it's transparent to the pilot. The pilot has no interaction with the system. Whether that's good or bad is yet to be determined, and it'll be debated forever. But given the fact that the Ethiopian crew, based on the AD that came out after Lion Air, was supposedly informed about MCAS. They were trained to what MCAS was. They were trained to revert to runaway trim procedures to counter the MCAS triggering or an MCAS event. Even with that knowledge and that training, they still failed to follow the procedures and still lost control of the airplane. So what good is it to put it in the manual if these guys don't use airmanship and follow procedures and stick by those procedures and fly the airplane?
You hit it on a minute ago. If you start putting all these in the manual becomes huge. You have to teach the system. One time I flew in the cockpit from DC to Los Angeles, and it was on a brand new airplane. And after takeoff, the blue, which is an advisory, light came on for hydraulic system. And the two crew members looked at one another, and one of them said, what's that mean? And they spent way past Denver, so from Washington, way past Denver, trying to find out what that meant in the manual. They couldn't find it anywhere. Thank God it was only an advisory, something, blue lights are not the end of the world. So they never found out, and they brought it up with maintenance when we landed in Los Angeles, and I wasn't part of that conversation, so I don't know what transpired. But it's impossible for you to put in the book in a way that you could find it when you need it, all of the possible faults that come up. You have to train the crew to recognize them and to understand the system well enough that they can deal with it.
In reading between the lines, if you will, the NTSB is critical of the fact that Boeing used test pilots. Guess what? It doesn't matter whether they're the test pilot or not. The fact is that they still have to demonstrate a compliance with the regulation that says that a pilot doesn't need to have extraordinary skills, this, that, and the other. The other part of it is they're saying, well, wait a second. The assumption that's built into the regulation and the certification criteria is that the pilot will respond immediately or appropriately. That's an assumption that's built in through the regulations. Boeing, Cessna, Airbus, they didn't come up with that. That's the certification criteria. And so the onus, to put that onus on the manufacturers to vet who the pilot or pilots may be on that airplane, that's not a manufacturer's responsibility. Where's the airline in determining the requisite skills, abilities, knowledge, qualifications of the people that are flying in the front end of that airplane? A 200-hour pilot would never see the light of day in the front end of a 737 flying passengers for hire at a major airline here in the United States. That's why we have this 1,500-hour rule, because we were concerned about lack of experience and lack of skills, abilities, and knowledge and a variety of other things. Not to say that a 500-hour pilot isn't well qualified and has skills, because we've seen that through ab initio programs. I'm a product of Embry-Riddle. I know the kind of training that those folks get there or at UND, University of North Dakota, or other flight schools. So I'm not critical of that, but I am critical of the fact that they want to shift the onus or the responsibility to a manufacturer that, we're going to take this airplane, we're going to make it so intuitive that if the pilot screws up or has a shortcoming or a deficiency, the pilot is going to be covered by the airplane. That is just fundamentally wrong.
So as we automate the cockpit on these airplanes and the next generation, because that's what these recommendations will get to, right, and we build in more automation, what are we going to do about complacency? Right? When you have a pilot just sitting there looking out the window. I mentioned it a minute ago about that one pilot that hadn't flown the airplane in 90 days, even though he was a scheduled pilot. Right? What's going to happen? Right? We're going to jack up the complacency. You can't change one thing in the system without it affecting many other things. And we need to take a look at that. And I get back to what I said in the very beginning. When I get on an airplane, I want a pilot that knows how to fly first.
Yep. Absolutely. And fly mean not just push buttons and hope that the automation is going to keep them out of trouble. It is very frustrating, because I believe personally that it's an insult to the industry, to those people, men and women, who work very hard to go through the highest levels of training to fly passengers safely all over the world. And the fact is that now they want to take that skill, ability, knowledge, and experience and basically poo-poo it and hope that the airplane will cover for them. That is the whole reason that you aspire to the highest levels of aviation in this particular instance. It is flying passengers all over the world in these highly technical airplanes. But you got to be a pilot. That's why we go to pilot training. My first blush when I read this is an obvious start to a pilotless airplane. The fact is they want the airplane to be so intuitive that now you don't need a pilot because the airplane will figure it all out and it'll be successful. That's not true. There's been discussion that you and I have had in the past about some of the stuff that's coming out. No, we don't need 2 pilots in the airplane. We got rid of 3. Now we're down to 2. We don't even need 2. You just need 1. Because if the airplane is acting as the other pilot, then so be it. Well, guess what? That's fundamentally flawed as well. And I think we're still on the board when you start looking at these accidents where you had an in-flight fire where a crew member had to leave the cockpit to go see what was on fire in the back or figure out what was going on. Who's going to be left up front? You can't take this down. You can't take the human out of this equation. And like you said earlier, with the Miracle on the Hudson, if that was an autonomous airplane, that is no pilots up front, what would the machine have figured out to do? I doubt it would have been to put it down in the Hudson River.
I think it would have tried to go back and then ended up as a burning inside a very populated area. Yeah, Sully had a tough decision to make, and he made in hindsight, he actually made the right call. But boy, I'll tell you what, the pressure had to be on him to make that call in the beginning.
Exactly. And guess where that call came from? Experience. That's what it's all about.
Yep.
And to say that this is a manufacturer's problem going on with the 737 MAX, I know a lot of pilots, you know a lot of pilots that fly this airplane. They think this is the best flying airplane they've flown. And the fact is that they are pilots. And that's what we are, we've been talking about. We'll let the facts come out. If the facts in toto come out, because there are some questions about how these investigations are being conducted under ICAO Annex 13 and whether or not both organizations, that is the Indonesians and the Ethiopians, are actually following those protocols. That too is going to be very interesting. It's going to be interesting to see how far they get into the maintenance and the training and all of these other aspects, rather than pointing all of the fingers away from themselves and their flight crews and pointing it at FAA and Boeing. Are there issues that need to be addressed? Absolutely. These regulations for certification were written in the 50s. They started well before that. Do they need to be reviewed and updated? Yes. Does it need to be a blanket overhaul and they need to start with a clean sheet of paper? No. The fact is that they have a fundamental basis. They should be reviewed as part of every accident investigation, which we have. At least I know that here in the United States. We looked at it with the 737 when they had the rudder issues years ago. We've looked at it with 747s and engine issues and a variety of other things. The fact is that it's been taken to an extreme now, and all they want to do is say that this was a bad airplane. But you got to have pilots who fly the airplane. And so you and I are going to have these continued discussions, John. We're getting on the high horse. We're going to start really ramping this up. This was just the start of it. I know that we're going to come back to it in future episodes. And I know that, and again, we hope that the listeners out there will send us an email. You can contact us. Tell us what you want to hear. Tell us what your opinions are. I know that, John and I, we express our opinions. That happened today. The fact is that we want to hear your feedback. We will answer questions. You can contact us at flightsafetydetectives@gmail.com. That'll get to us. We'll read the questions. We'll talk about the issues you want to hear about. We'll do the research. We'll give you not only the factual basis, but of course, our particular opinions with that. We always appreciate the fact that we have our listeners. You go to our website and you'll see that we're going to be posting a lot of information. And I know that John has always got to have the last word.
I just wanted to say that I've had well over 100 people write into me, email into me with questions and subjects that they'd like to see us talk about. So there's no shortage of subjects, and we're going to go after the news of the day as well as the systemic problems that we have. And one last thought I have on on what the NTSB put out, which I thought was very unusual, is they had to go and add a sentence that said that they have had access to the information. I mean, that should be a given. Why are they saying that? Maybe the reports that came out early that said that the NTSB and others were denied access to the information, and that's why they sent the recorders to France on the Ethiopian case. Maybe that's why they put it in there, because they were denied access in the beginning, and now all of a sudden they have it. But anyway, that's speculation. We'll talk about that as time goes on.
So with that last word, I'm going to sign us off. So for John Goglia and myself, Greg Feith, fly safe.
To listen to more episodes of the show, go to flightsafetydetectives.com or the Professional Aviation Maintenance Association at PAMA.org, and wherever you find your favorite podcasts. Catch us next time when John Goglia and Greg Feith talk about all things aviation. Thanks for listening.